All right, let's see. I think it works. Yeah, it works. Okay, so as I promised earlier, I put together a bunch of practice problems. I think there might be 8 or 9 in here, right? So I'm I wanted to make it an assignment because I wanted to give you guys a real incentive to do it, even though I think most of you will be incentivized to do it anyways. But it's an assignment. It's due next week. I'm not expecting you to do all of them. Okay. There is a wide variety of complexity and breadth of coverage of topics, okay? And I hope you can see that in here and maybe pick and choose the ones that are the most valuable to you to complete. But I would say at least take an attempt at all of them so that you're at least thinking about it, yeah? Whether you master them all or not, that's not the point, right? But like, definitely like, get a sense of all of them. Try them all. Some of them should be fairly straightforward. Some of them really build into complex stuff stuff like we just put on the board today. Okay. Feel free to post any solutions to this to the discussion forums between now and next week. I don't mind about that at all. And I think, frankly, I'm okay with that for all the assignments. I believe I've said that for the 3 or 4 stuff. The real exam will not be this long. Okay. So this is not meant to be a practice exam. This is meant to be a bunch of practice problems to help us to get to the exam. Okay?
So,
yes?
How do we get full credit for this assignment?
If it looks like you did a bunch of them,
Okay.
I am not going to very carefully grade it. So if you submit 2 or 3 and they look like the good MATLAB code, you'll get credit. Okay. Yeah.
Since I saw some problems with like bonus, still could be like bonus like problem like extra points.
I'm not giving extra credit on this assignment, but the bonus is to say, hey, maybe this would be an extra credit on the exam.
So the might be possible.
Possibly. So there's a bunch of bonuses throughout. It's to kind of get you to see if, hey, can you take a problem to another level of complexity? And maybe on the exam that would be an extra credit. So why don't we give it about 10 minutes for you guys to just review them all. And then if you guys want to, we can pick out a couple that we do together. Or if you want to just take a crack at it on your own, that's fine too, right? But I think for some of you, doing them together would be helpful, right? So let's do that. Okay, so let's give it 10 minutes. Please read through all of them, get a sense of what they look like. Yeah. So factorial, what is the definition of factorial? So n factorial is equal to n times n minus 1 times n minus 2. Okay. Actually, I mean, the better way to do it is probably from 1 up. So it's, sorry, hold on.
The end. Would you put like a sigma notation this on how high it goes up to? How does that work? No, so just n is the number.
Sorry, did you say sigma? Yeah. So that's a great question. Sigma would imply a summation, right? And there's no summation. This is multiplication. Okay. These are multiplies.
Yeah, no, I get that. I'm just thinking like, okay, what's the end though? How do you know when to stop at the end?
It would be like 5 factorial, and the last number would be 5.
Because n will actually be a real number.
Yeah, I see. Yeah, I get it now. Yeah. I mean, it doesn't matter which way you add. Sorry, it doesn't matter which way.
Right, it's multiplication. Yeah. Okay. Sure.
You'll see it a lot when you get into statistics. I mean, that's
Yes,
okay. So what is our algorithm look like? What's our pseudo thing look like?
Storage.
This is the number 3, I think.
Yeah, it's number 3.
All right. Well, let's look at the code. Let's look at the problem.
So we would need to set a vector. We would need to create a vector for n, maybe.
Okay.
And if we're saying that it's going to be 10, we would want it to be 1 through 10. What's saying possibilities of 4 digit pin code, right?
Yeah, so 0 through
Oh,
six.
0 through 9, but 4 times. I'm not good at I don't know what I want.
Let's not even think about it as probability. Let's try to simplify. It's only thing about factorials, right? So we have this definition for factorials, right? Is everyone okay with this, like conceptually? Yeah. Okay, great. So what is this? Let's start with a pretty high level algorithm and dig down. Shall we do that instead? So I think the first step in all this is always to kind of set it up, right? So what are some things that we're going to have to do to set this problem up before we do any math or complicated stuff based on the specification?
From
Vector 0 to 9.
or vector from 0 to whenever. Or 1 from whenever.
Let's look at the problem statement again.
0.
Well, 4 by 9. I don't know.
What's so funny? Oh, somebody's singing? Is it good?
Honest.
It's honest. Are we going to always be dealing with 10 and 4?
No, so we're asking the user for input.
Yeah, okay, so good.
Does that.
First step, input N and R. And it may seem like, oh, well, of course we're going to do that. But I want to do this now to get us out of the mindset of like thinking about 10 and 4. I want to think about this as
And we're only going to do the calculation once, right?
correct. What do you mean by once?
The actual value of P is only going to be, we're only going to have one result.
Correct.
Yes.
Yes.
Oh,
At the end of this, P has one value. Okay, all right. Input N and R. What are we going to do next?
We have to, I would go into calculation.
Okay, so let's do some calculations. Is there a way for me, because this looks complicated, dude. There's 2 factorials. I don't know how to do it, right? Is there a way for me to split this up a little bit if I needed to simplify my work?
The top and the bottom.
Do the top and the bottom. Do the numerator and denominator separate. So let's do that. Let's do
Define input.
calculate numerator. Okay, sound reasonable? So I've broken it down to something I think is more manageable, a little bit more manageable, right? What's the last thing I need to do? Yeah, actually, I don't state print it out, but let's add it here. Yeah.
In program.
So write it down. Okay. I'm sorry. Just like it, right?
So when you say pseudocode, you're saying like the process.
So yeah, so I'm calling it pseudocode. I believe the author Han calls it structured plan. But it's like the way to think about it is it's kind of like English language stuff that is very much the steps your program is going to take.
That would be our comment.
Yeah, and that's exactly how Han does. Han says, develop your structured plan. Then he says, copy and paste that down to where you're going to write your code. And in between every single line, write your code. I would say it's a starting foundation to your comments. You might want to still add stuff to it. But yeah, definitely that's Han's strategy is use that as your starting foundation. I do want to dig one level deeper here because I think it'll help us. And that is to take one of these, calc numerator, and figure out, well, what does that structured plan look like? So the question really is, can you guys help me do a structured plan? Remember, and I treat this as synonymous with pseudocode. Pseudocode for calculating n factorial. So what basically I'm saying is I want to dig into either one of these. But do it separately. So forget about this for a second. Simplify it. Let's just do n factorial. What does the pseudocode look like for n factorial?
a for loop for,
Okay.
I mean, it's gonna need to multiply by like a number, one number below it. So like and -1. So we'd have to have like a subtraction, I guess.
Okay,
Yeah, like
there
change
could
the
be.
value and then multiply all of those together, or
Okay, so we have a for loop. So the other way to talk about is repeat for loop. Okay, what are we going to start with? So any for loop is going to have a start and an end in some interval, or it's going to pull values out of a vector. What are we doing in this case?
We're taking the initial value of n and we're multiplying it by 1 minus n, and then multiplying that by, or n minus 1, and multiplying that consecutively until we get to 0. Or
Okay.
until we get to 1.
Okay. So, like, if I were to just ask you, okay, well, what is my vector? What my loop vector look like? My
1 to n.
Yeah. What's it look like?
1 colon n.
Yeah. Everybody okay with that? Like, what values are in here? These values, right? Depending on the one. Does that look familiar? Yeah.
You're saying the user specifies it, right? That's the input.
Yeah. Yes.
Yeah.
That's right.
Yeah.
What do you specify as 1?
It would be, and 1 factorial is 1. Yeah. You okay with that? Yeah. Okay.
And
Good.
isn't factorial of 0 also 1?
There's some weird rule about it.
Yeah. Really? So you'd end up with 1, it wouldn't be undefined.
Yeah. This might be a corner case. Let's not worry about the corner case. And depending on how we execute the code, 0 may not come out with it. Yeah. So what do you think? What do we? I think you guys have said this, but like, help me write it. What am I doing every time in the loop?
So it's going to be
whatever. So some. Let's just call it result is going to equal. So the result
plus.
is it plus?
plus times.
Times?
Times.
You want to multiply it,
Times.
Oh, right.
And what are we going to multiply by?
for
The index.
Whatever number we're on, right? Okay, good. So here we go. I'm done, right? This is good.
But you would want to initialize the result as 1, right?
Yeah, you would need to do that. Where should we do that?
Outside of the loop.
Outside, okay. Okay. What else do we see here? They're good? It is good?
That looks pretty good. I think
It's
the
good.
result
Okay.
gave us a good number. Yeah, well, that's just the numerator, right?
Yeah. So one of the reasons I said, hey, let's do the structure plan super high and tease us out was to also help us approach this problem, right? Help us approach the problem to break it apart into some components that we could more easily solve. The other reason for doing this and separating this over here is we're going to get to this later. I haven't gotten to it yet. But this problem is ripe for using something called functions. Okay? Up till now, we have only done what's called scripts, or programs, if you will. Okay? This is a basic function you might want to perform, and you might want to perform it many times over and over and over, right? That you may want to do factorial for the numerator, and then for the denominator, and maybe somewhere else in your code, 100 lines down, you want to do factorial computations again, right? So rather than having that piece of code be replicated in multiple parts of your program, there's one way to do it. You would actually write a separate program with slightly different syntax, and you would explicitly create that separate program into what's called a function. You would make your own function. Now that has all these built-in functions we talked about, you would make your own custom homemade function. And then in your script, where you say calc numerator, you would actually call your own homemade function. It would do the math, and then come back to your script. And then you would get here, it would call your homemade function, do the math, and come back to your script. We're not going to do that here, but this is just sort of opening the door to that. We will do that later, maybe in 3 weeks or so. We will do functions. But that, we're not going to do that here. We're just going to keep this simple and repeat this. Oh, that's fine.
So do we need to do a nested for loop because for the denominator we're doing R and N.
It keeps it easy. The easiest way to approach this is to do it for the numerator with the value n, do it for the denominator with the value n minus r. Do the n minus r work first, then do that. Yeah, that's the easiest way to approach this. Shall we look? Shall we write this, or is this good enough? Do we feel like this is enough to get us forward?
How would you put it? How would you calculate this results divided by?
I would have two variables. I would have a result variable for the numerator, the result variable for the denominator.
The result over there.
This result?
Yeah.
Let's take a vote. How many of you want to see it done for real? How many of you are happy with this? It's an even vote. Done for real. All right, done for real.
Done for real.
All right. So I have to change this. Sorry about that. So. Okay, so. Where are we at here? Nope, I'm gonna go. Nope. Come on, really? Oh, certainly would help if I put it in.
You want it to go? I want it. So one thing that program will have it, but one thing that we do input the LNAs.
All right.
They really are because like I said, car type, and then I convert them back to numbers. And if they weren't originally a number, then they could convert it to enter a number, not a letter. And so
Okay, which problem number was this?
3.
3? Okay.
I want
Edit. Okay, that's not what I wanted to do. Turns out there's a built-in function. Oh, that's permutates matrices. Never mind. That's not what we're on. Okay, that was not what I wanted. Okay. Okay. How do we start? Input. Okay. What do I want to input first? N. Okay. What should the prompt say?
How many digits are we considering?
What was the nomenclature we used? We said objects. Let's stick with the nomenclature we have here, right? Yeah, we need zoom in. Okay, hold on. That better? Yeah. All right. Okay, and then we got to get R, right? What do we call that? Enter number of objects. Okay. Just being really strict to this sort of the theoretical aspects of permutation calculation. Okay. It's referred to as objects and number of objects taken. Yeah. Okay, great. So what do you guys? Now we have our N and our R. What do we have in our pseudocode there? We're going to say calculate the numerator. Okay, so let's do that first. Compute n factorial, which is the numerator. Okay. What do you guys think? For loop? Yeah. For loop, okay. For, let's call it the mult value equals Guys, how do you guys feel about that line? Everyone's off, dude, off to the races. This is great. Are you sure you guys want me to do this? You guys are off to the races. I don't need to do this. Wait, what did I forget up here? Yeah. Okay. Let's call it num result. Yeah. So, okay, here, I could get away without this. So the question is, why do I need the brackets here? Explicitly, MATLAB would permit me to do this because the colon introduces the brackets, if you will. The colon creates a vector. Okay, now, so with the colon, I could get away without brackets. But if I was doing 1, 2, 3, 4, MATLAB would get upset about this if I did not have the brackets, because the brackets say I am defining a vector. There's my vector. Okay, and 1:8, you get to cheat. Like this is a vector. You don't need the square brackets, but I have a habit of just doing it. It just, for me, it works better. But yeah, technically you can get away with it. How do you guys feel about that numerator calculation there? Is that okay? So like I said, we're not going to do a function here, so that means we're basically have to repeat the same code twice. But I am going to use different variables here because I want to keep track of my numerator. I want to keep track of my denominator because I'm going to do some division later, right? That's how I get to P. So I'm going to use some different variables. I can reuse some of them, but not all of them. And I'm just going to be lazy, if you will, a little bit and do this right here in the for loop at n minus r. You could do it outside of the for loop. You could do it before the for loop, but you don't have to, right? Voila. So those are my two factorial computations. One that's going to do n factorial. The other one that's going to do n minus r factorial. Yeah. Any questions on what we have so far?
If I use the n minus r when you multiply times multiply, how can you do it right there?
Sorry, is the question why do I do it right here? Yeah. So if I think about this n minus r factorial bit, right? Think about order of operations. Right? If I have this, mathematically what I have to do first is this n minus r bit. So that gives me a new result, right? So this gives me some new result. Let's just call it y. And so all I'm doing here is saying, hey, start at 1 and go up till n minus r. You know, which I substitute as y. So what do I need to do now that I have my numerator and my denominator? Yeah. So compute notations. Q equals numerator result denominator. I'm just doing this to show you, you can easily mix text and variables. Oops. Oops. This is getting a little long for this font size. We'll fix that in a second. Those 3 ellipses allow you to continue commands on the next line. This should work. I think those 3 ellipses will work.
Yeah,
in
that
this
would
instance. Wait, nope, they won't. These ones are in the wrong.
Not inside.
These ones are in the wrong spot. Yep. Those ones are in the wrong spot.
You just got to do it before the. Yeah.
Can we run it?
Yeah. What is the button for forward delete? Is that insert?
Huh?
When you forward delete, when you delete the space in front, what is that?
Delete versus
This
backspace.
is the button delete? Okay.
Yeah. So in our example, we had 10 objects, right? 0 through 9. Those are, and that means the objects are 0, 1, 2, 3. If you were dealing with, say, a regular die, how many objects would you have? A regular gambling die, right? 6, right? You'd have 6 objects. You have 1, 2, 3, 4, 5, 6. Here we're dealing with digits 0 through 9, like a typical ATM PIN code, 0 through 9, so you have 10 objects. If you're familiar with, like, I'm trying to think of, like, let's say if you use the alphabet. Say if you have alphabetical characters, A through Z, how many objects would you have? You'd have 26 objects, okay? If you were allowed alphanumericals, meaning you could have 0 through 9 and the alphabet, how many objects do you have? Say if you could allow capital and lowercase plus numbers, how many objects do you have? Right, so you can see how you can get into a lot more permutations very quickly by having those, by varying your objects. And it's one of the reasons why when password stuff, when you have password requirements, one of the reasons they are interested in caps lowercase is because it really makes bigger the number of permutations that some cracking software has to go through to guess your password. So there's practical implications to all these homeworks and exam questions, as annoying as they may be. Okay, so we have 10 objects, yeah? And this is a 4-digit PIN for the ATM, right? So how long do I have to stay there to guess your ATM PIN? I have to try it 5,040 times. Is that right?
You were expecting it bigger?
I think that's okay.
I guess so.
I mean, I can do the math. Yeah. Well, you just did a MATLAB. Factorial 10 divided
Yeah.
by factorial 6.
Yeah.
Are you rethinking your personal security?
Well, do the check. Do the MATLAB function validation.
Yeah. I need to think about it some more. No, I believe it's right. Sorry. Okay. Yeah. What is it? We did 10 factorial, right? Factorial 10. Okay. And then factorial 10 minus 4, right? Yeah. So let's do this. There you go.
That's all you
Cool. You guys want to do a different one now?
No, you scroll, huh?
Yeah.
Sorry, you want to look at the code? Do you want me to scroll up or look at the code? I'm going to make it a little smaller so we can see the whole thing at once. If everybody wants to.
Are you displaying?
Yeah.
All right, so you guys want to do number 4, right?
Yeah.
Oh, this is my favorite. All right, you have been hired by Elon Musk's new venture, Boring Ski Resorts, to help plan for operations of a ski resort that's going to be placed in Lancaster, California. Now, if any of you know where that is, it is not an ideal location for a ski resort. And it's quite a flat location. There's a little bit of a grade. It might be like a 0.5% grade. It's actually over the hills. It's closer to. No, it's like in this weird spot, like a. It's not in the Central Valley. Yeah. Palmdale. Yeah. I barely knew either until I went there. So this crazy guy Tusk has hired you to figure out how many hours will there be snow making opportunities. Because that's what we're going to do. It's the desert. We're going to make snow in the desert. In order to do that, you're going to determine how many hours are 32 degrees Fahrenheit or colder. That's our assumption for making snow. As long as it's 32 Fahrenheit or colder, you can make snow. Now, if you know anything about snowmaking, there's actually a whole bunch of other factors that are important. It can't be too cold, it can't be too hot, and the humidity has to be just right. But we're not going to worry about any of that. I could complicate this problem if you really want me to get humidity data and go with that. Let's not do it. All right, there's a CSV. That's the comma separated value file, right? You guys remember that? We've used it a couple times? Yeah? Okay. I have already removed the header and columns and all that kind of stuff, so the file should load just fine. If it doesn't load fine, we'll discover it. Okay? That file contains temperature data, hour by hour. So each row is the next hour. Is that cool? Yeah? Any questions so far? All right, great. We are being asked in our script, and once I have the data in a vector, to basically determine the number of hours where the temperature is less than or equal to 32 Fahrenheit, and the number of hours where the temperature is greater than 32 Fahrenheit. And then we're going to provide a plot of the temperature data, format it really nicely, and then we've been asked to make a title, and we're going to make a title dynamic, right? Which we actually just did over there. Remember we did the R equals and the number change all the time? That's all I'm asking you to do. Same thing that we did with the R equals when we had the 7 subplots. And you know how the R equal changed for every one. Here, I want the title to display the result of your analysis. Okay? We cool with that so far? Okay, so let's do our. Okay, so let's do. What is our plan? What is our structure plan look like? Well, before we, I hear create the graph. Before we create the graph, what do we have to do first? Import data, right? Get the data. Okay, then what?
Calculate how many hours.
Yeah, so determine, what's that?
Save it in MATLAB?
Yeah.
That import data save MATLAB. That sounds same thing. Import data is bring the data into MATLAB.
Probably some if else statements to kind of count the numbers of hours.
Okay, so yeah, so we have to count hours where t is less than or equal to 32. Okay, great. I think we do need to dig into this a little bit deeper in terms of our algorithm or pseudocode. How are we going to do this? Can we do it just like with one command, or do we need a bunch of commands? What types of commands do we think we might need?
Can we load it in there? It's like a vector.
Well, it's going to be in a vector when we do this import. Right? Import data.
Can you like a vector conditional? Where we take the data that's greater than.
If that was what we were going to talk about today, let's not do that. Yeah, let's not do that.
So, okay, so we want to calculate the number of hours where the temperature is less than 32. So we just input data of temperatures, right?
Yep.
Okay, so we want to index through the vector that we have.
So how do we index through a vector?
A for loop.
For loop. Okay, so this is going to be a for loop. Okay, so we are going to loop. We're going to use a different pen. Loop through temp data. Gesundheit. We're going to loop through the temperature data, right? And at each temperature, what are we going to do?
We're going to just check it.
We're going to ask some questions, right? So for each temp value, check if temperature is less than or equal to 32, right? Yeah. We'll do that one by one, right? Yeah. So let's say. So what do we do here? Because we got a conditional. We're checking, right?
If it's not, go back to the beginning of the loop. If it is, you want to store that value somewhere, right? Yeah. Or set a marker.
Well, let's keep it to the simple.
Oh, I don't know. Maybe I didn't read the whole thing.
Let's keep it to the simple version of this right now, which is just all we're asking to do is calculate the total number of hours that are good for snowmaking versus not.
Can we make it into like a vector, just keep adding on to that vector? And then
So-
just count that at the end?
Okay, so that's a great question. Could we just make a vector, could we build a vector and then at the end count that vector? You could. At least the problem up to this point, there's an easier way to do this, right?
What I would do is I would have a counter that was just a value that was originally
A
1
scalar.
or 0,
Yeah.
scalar.
A
And
scalar.
then it started 0. And if
Okay.
it was yes, I would add 1 to it.
Okay. So we'll call this the snow scalar, and then the no snow.
You would so we want to keep track of hours that aren't also.
Yeah.
Okay.
Yeah. 3, 1, 3, 2.
That's why I originally I was just thinking about ones that were. And that's why.
Okay. Now, remind me your name again.
Andy?
Andy. So Andy brings up a good point. Maybe we want to keep track of this. Like maybe we want to keep track of which hours are good for snowmaking, which hours aren't. And actually, that turns out to be, if you look later in the problem, that's basically one of the later ideas.
I honestly just didn't know I could do that.
Oh,
That was my method of solving it.
Oh, you weren't thinking about this.
No. I wasn't thinking of like that, like the counters. I was just thinking maybe.
Build a vector.
Yeah.
So I think if you went down that route, you'd have a solution. It would work fine. No big deal. Yeah. This is
It's not as efficient.
perhaps a slightly more efficient way to do it. Yeah. Yeah. But the cool thing, Andy, is that if you do it that way and you do it somehow, you can actually do this open-ended bonus, which is make a visualization that shows me the hours that has on the plot. These are the hours you can make snow. These are the hours you cannot make snow. And it's very open-ended, meaning like you could do it by using different markers. You could use it by changing the color. You could use it by doing a bar plot. I don't know. It's up to you, right? I totally leave that up to you. But we could play with that a little bit. Let's do the first part of this, which is only keeping track of the count. These are often referred to as counters, counter variables. We're just counting. If this hour is good for snowmaking, increase the value of that count by 1. If this hour is not good for snowmaking, increase the value of this counter by 1. So that does mean these two need to be initialized. In this case, where do we want to initialize? In the for loop? Outside, okay. And are we going to initialize the 1 or zeros?
0.
Okay, so up here, init, counters, 0. And then of course, there's a couple more things here. I think it's just, oh wait, sorry, it's just plot and put the numbers in the plot. So that's really the next thing that happens. Right? this is detail for this part, right? And then the last thing you're gonna do is plot. What's that? That's kind of what our pseudocode or our structure plan looks like. You okay with that? Shall we try writing it up?
Yeah.
Do we need a break? I'm just thinking, what time are we at? Oh, let's let's do this and then do a break. Is that good? Yeah. For this one? Okay. We are, the department is well aware of the shared situation. We seem to be doing much about it. Other than complain. What's that? Huh. I should be careful what I say. This thing's being recorded. I'm slowly going down in the world. You ever guys feel like this? This is horrible. Okay, there's a reason why this chair was over in the spot it was. You know, I wish I was moving up. Going down. Ah, all right.
Is that cereal?
Oh my gosh. You guys are hilarious. You make this class really well worth it. Which number is this? 4. 4? Okay. Okay, so one of the first orders of business I should take care of is get this file into my computer or my USB stick or whatever. For sanity and simplicity's sake, where should I make sure the CSV file goes? The same folder as the script, yeah, which may or may not be your MATLAB folder, but the same folder that your script is in. So I'm going to click on this, and of course the default setting on here is to put it somewhere else. I'm going to say show, and I have to remove it from there and put it where I want it. Oops, not that one. All right, good. So my CSV file is now there. Great. So based on my structure plan, what should I do?
Loaded.
Yeah, I can import the data using the load function. Okay, what's that look like? Load? Oh, I want to put it in a variable. Okay, what should I put it in? This isn't snow data quite yet, is it? It's temperature data. I like it. Temp data. Let's do temperature. I caution. I had initially I just like went temp data. I caution against using temp to mean temperature. In computing land, temp usually means temporary. So try to stay away from temp for temperature and type it out, or actually just use T instead. Okay, load. So I need the file name. All right, let's see, what's it called there? So?
Those are the wrong kind of.
Yeah, single.
Oh, right, this one's really picky about this, right? All right. Cool. Should that work? Let's try it. I don't believe that's gonna work. Yeah, it looks like it worked. Oh yeah. And you know, before I get going here, I could do this. I could just be like, okay, well, okay, what is, let's see here. Load. Load. Oh, look at that. And I could do this. I don't even have to go very far. Just like, let's make sure this stuff is there and it looks good. Great. I didn't do this in code. I just did this on the console. This is one of the beauties of MATLAB is like, you can quickly just do some stuff in the console if you need to, right? Does that look pretty close to the picture in Canvas? Let's see. What do you guys think?
Yeah.
It's got this daily pattern, right? That's kind of what we experience in real life, so that's good. There's this one day here, the temperature doesn't drop much, but that's okay. Yeah, looks good, right? So I got my data, the load works. Let's go back to there. Okay. All right, what do we do next?
This is what we're writing?
Yeah. You guys need a break now, don't you? You guys want the break now?
I was writing something else. I just kind of.
Yeah, let's initialize the counters. Okay, good, good. What do we call them up there? Snow hours? All right.
We're gonna enter a for loop at this point, aren't we?
Yeah, we gotta do a loop, right? We're gonna go through our which
Okay.
variable?
The temperature.
Yeah, okay, so for, what do I want to use as my index variable?
Temperature index.
Okay. Temp I. And what do I want to use as my index vector?
I to length of the temperature T.
So I'm going to build a vector here. Is that right? Square brackets. And I'm going to start with 1 and go to.
Length of how much there are.
Okay. How do I tell MATLAB to do that? Length, parentheses.
And then CSV file or temperature.
I want to do it a vector. Yeah. Which vector do I want to give it? Temperature D, right? Okay.
Oh yeah. That we need.
Yeah. Once you've got the CSV file, there's no reason to go back to it. Once you've loaded the CSV file, you have it in a vector. Work with the vector. No need to go back to the file. Most cases. All right, great. I just want to be super clear with everyone on this. In the way that we have constructed this for loop, what is the value temp I is going to take? Is it the actual data that's in temperature data, or is it the indexes? Okay, so the plan that I'm approaching here is the index. That's totally cool. Good. Now what?
Conditionals to check.
So now I need to check. Okay, so good. Check if we can make snow. Okay, so what does that check look like? If so what we're going to do now is say, okay, we're in our for loop, and we're slowly going through our temp vector, right, one by one. So we're starting with the first row. The index for the first row is 1. So say, we're basically saying, hey, go to our big temperature data vector, find index 1, grab the data from that, and compare it with 32. Is it less, sorry, is it greater than or equal? No, wait, why did I put greater? Is it less than or equal to 32, right? If it's less than or equal to 32, what am I going to say? That's a snow making hour, right?
Yeah.
So what should I do if it is less than or equal to 32? So I want to increment the snow hours, right? Snow hours equals snow hours plus 1. Okay, and then do I need to do an else? If an else, what should I do here? What do you guys think? Else. I can just get away with an else here. Yeah. Else. And what do I do in this else case?
No snow hours.
And then am I done with my conditional, or do I need to do something else here?
And
Okay.
and again.
Do I need to do more of my for loop? Sorry. I need to do more of my for loop. Am I done? Is that everyone okay with that? Any objections? All right. Oops. EMD. That's something different altogether. Okay. So, how do we feel about this for loop, guys? It's a for mixed with a conditional. Questions? Yes.
Where is that +1 coming from?
So when I have a counter, I want to slowly grow it. often counters are going to grow by 1, but not always, right? So what am I trying to do here? I'm trying to get a total number of the hours for which I can make snow. Right? So I'm going through my data. Let's make some fake data for us. Imagine I have some data. So let's say I've got, this is my temp data. Okay, and then what do I call my variable? Snow hours, right? Snow hours. Okay. Is temp data a scalar or a vector? Vector. Yeah? Is snow hours scalar or vector? Scalar. And what do we mean by that? Snow hours is going to have one value, just a single numerical value. Temp data is a whole bunch of values. So let's just draw that out. It looks like in one hour it's 45, the next hour it's 43, and all of a sudden it gets really cold. It stays cold for a while, and then it starts to rise again, like so. Okay? Let's pretend this is our temp data. Okay. So what we're trying to do here in the for loop is say, go through this one by one, hour by hour. Each row is an hour, right? Go through it hour by hour, and as you go through it hour by hour, decide if you have a snow hour or not. And if you do, increase the count of snow hours you have experienced. And at least in this algorithm, in this approach, what we're trying to do here, we're going to increase it by 1 hour because we're doing this 1 hour by 1 hour. So let's think about it. We start, when this program starts, snow hours is what? We initialize it to 0. Snow hours is 0, okay? We do our for loop, and we look at this value. Okay, we do our conditional. Is 45 less than or equal to 32? No. Do I change snow hours? Let's just put up here the other scalar as well, okay?
Kilowatt hour.
Yes.
I initialize both to 0, right? Snow hours and no snow hours are both initialized to 0. So I'm looking at 45. Is 45 less than or equal to 32? No. So which of these, based on the code that I have there, which of these am I going to add 1 to?
No snow hours?
That's correct. So this is now 1. Okay? Great. I'm done with my conditional. I'm done with my this iteration of the for loop, and I go to the next iteration of the for loop. So now I'm going to look at the number 43, right? Because that's temperature D index 2. Looking at the second index, second element, is 43 less than or equal to 32? No. What do I do with my counters based on that code? Exactly. So this, remember, this is a scalar, so it only has a single value. It's not keeping a vector, it's just a single value. We have 2 of them. Great. That was my conditional. Come back here, and now I go to the third element, which is 30. Is 30 less than or equal to 32?
Yeah.
So what happens to my counters?
Snow hours.
Snow hours goes up to 1. Does no snow hours change based on our code? No, not at all, right? If I muck up my code and I screw it up, it might, but the way it is right now, it won't. Good. I go to the next value. I go to 31. What happens now with my counters?
Plus 31, so snow hours is 2.
Snow hours goes to 2. Okay. See the pattern?
Yeah.
Okay. Good. Now, if yeah.
Oh, that's it.
I was gonna just throw out a hypothetical. I don't want to. I hope this doesn't confuse the matter too much. Okay. But to just show, like, to answer your question, Dimitri, where did the 1 come from? Okay. Let's pretend for a moment my temperature data was daily data. That means this is day 1, this is day 2, this is day 3. But my request to you was still, tell me how many hours. So now I'm going through my for loop and I do day 1. And actually, let's actually pretend to write it out. Okay. Remember, these are hours. I'm going to call this day 1, day 2, day 3. And this is the part that's very algorithmic. It has nothing to do with MATLAB. MATLAB can never help you with this kind of problem. This is all up to us to solve. So I do my for loop and I do day 1. On day one, the temperature is 45. Is that less than or equal to 32? No. Okay. How should the hours change? Right now they're both 0. How should the hours change?
Yes, no, I should go like 24.
I should add 24, yeah. So my increment for counting is 24. And the only way to know that is I have to think about the problem and say, okay, this data is daily. You're right?
Yeah.
Okay.
Yeah, I mean, that's better.
I know this is earth-shattering stuff we're doing up here, but. Okay. This data is daily, but I asked you to keep track of hours, right? So this increment is going to go from 0 straight up to 24. I go to the next line. On day 2, it's 43, right? How do my counters change? 48. So now this is going to become 48, right? Day 3, how do my counters change?
No hours turns to 24.
This goes to 24, right? And I would actually have to change that in my code. I would have to make this code look different. I would make it look like this, right? And again, this is just a hypothetical scenario where effectively the time interval in my temperature data is different than the time interval I want to keep track of. And so this is an example of the counter not being 1. Does that make sense? Yeah. I'm going to change it back to 1 because our problem needs 1.
If you really want to, you can counter variable. So you want to change this.
Yes, you could do an increment, or you could actually you could just do a divider or something based on your source.
So I wonder if I can change the temp I equals to the temperature D.
Yeah, okay, so that's a great question. Are we okay with this, what I just said here? Okay, there are a whole bunch of other ways we can approach this problem. And so Juan had just asked us, hey, well, what about, do I have to really go by the index? Can I just use temp D as my index vector? I think that's your question, right? And you can. Let's just duplicate that right here. I'm going to copy this for loop and say another way. And what does that look like? That's like, let's call it this temp. Oops, what did I do there? Let's call it this hour temp. Yeah. Okay. So again, this is one of those like really nice features of MATLAB is you can do it the MATLAB way because MATLAB was built for vectors. It was built for you to take advantage of these vectors. What's the difference between the top way and the bottom way? The top way is built around using the index number. So my for loop starts with 1 and goes by 1s all the way to the maximum index I have, right? This second example, it says, what's the data in temperature? That's this vector, temperature data vector, right? And instead of counting 1, 2, 3, 4 like the indexes, it's going to say, take the first value out of this vector and put it in that index vector. Put it in the index variable. Do the for loop. Then take the second element out of this vector. Put it in the index variable. Do the for loop. Take the third element out of here. Put it in there and do it. You do it that way.
So will they increment the snow hours, or because I kind of did that way, but it didn't increment the hours.
Yeah, we were having trouble with this format earlier today too, and it was weird because in this we didn't put this hour temp. We got it to work by putting temperature D, and it was incrementing through the variable temperature D, and it seemed backwards. And I was actually I took a picture. I was gonna ask you about it.
If I understand right, okay, this is a tangent.
Kind of, and it was actually a real life situation earlier today.
If I understand, you did this, right?
No.
D.
No.
No.
We had an index variable name, which like you just had. But then in our if conditionals, we had to put temperature D.
You weren't able to use this?
No, it wasn't. That was you, right?
Temperature D instead of this hour, in place of this hour.
Can I see the code?
Yeah,
It's like from my assignment, so.
I have a picture of it, you know.
I mean, I would love to just bring it. Well, actually, can we finish this problem? And after we're done with that, can we look at that problem?
Yeah.
Okay.
Yeah, I just painted it.
Okay. So let's. Okay. If you, I understand what you guys are saying. Let's finish this. Okay. Let's semicolon there. Semicolon there. Okay. This. Okay. Oops. Oops, sorry.
So the second one, that's the first.
I didn't reset those variables. And actually, why did they? So something else is going on. Yeah, we're gonna have to look at it. Hold on. Oh, I know. Okay, this was with the CSV, right? Okay, I'll tell you what's going on. This is slightly annoying. And was this with the data from a file or not?
No, this was when we were just doing the population one. And he was trying to loop.
Oh, that might be the same problem. Okay, this is exactly what's happening. In the for syntax, the index vector has to be a row.
So we were indexing through anything.
It's by the specification of the for vector.
So they were trying to swap things.
So there's a very easy way to fix this. You guys remember?
Transpose.
Transpose. So let's do that.
Oh, well, no, that wouldn't have been our problem though, but yeah.
Are you sure?
I'm pretty, well, maybe.
There we go.
Transpose
Oh, wow.
like this.
So remember, the reason we have a column vector is that's what load is giving us, based on the way the data is set up.
Yeah.
Right? So the load is looking at the CSV. It's one big column in the CSV. It's making one vector. That's a big column. For wants your numbers to be in a row. If you're going to do that index vector, right? Sorry. So you're going to use the index vector as your data point. Transpose takes the column and turns it into a row. Right here. The transpose. I did it right here. You see that little? See that little apostrophe right there? Yeah, that's my transpose.
I think I had an issue with that image.
Yeah.
I couldn't get, so I had to go back to the index.
The index. It's because of the for loop needs it to be a row vector.
That makes sense.
Let's take a break, guys. Yeah. We'll do after the break. We'll do the plotting and the dynamic title, and whatever else you guys want to talk about.
So yeah, I just
Pause the video or stop the video.
It's like